All right. Hello, hello, hello. Hope everybody's doing okay. Um, Welcome back from spring break. This whole thing feels like a spring break at times. Um, Couple things before we start. There was a Google Classroom that you were supposed to join. It's a technology Google Classroom, right? I believe you've been given the code. So make sure you do that because there's an attendance sheet that Mr. Reyes wants you to fill out. You're continuing to fill out the attendance sheet on my materials as well because that's very important. As far as grades go, third cycle and everything. Third cycle, the grades that are in there now are going to be third cycle. There's just one more blank space for the essay, which I should be finishing up and putting in today. But after that is in that, and that's the genetic engineering GMO essay thing. After that's done, that's our third cycle. So this today is going to be for fourth cycle. I am going to collect this and grade it. It's just going to be for fourth cycle, and also the and from here on out, it's going to be fourth cycle. The next thing, uh, the next class we have is going to be just a quick slideshow and review. That would be Friday, and then a week from today would be a quiz, just to give you a heads up. But I'll talk more about that the next class. All right, before we left, we were talking about agriculture. We were talking about the Green Revolution. We were talking about crop rotations, how farmers learned over time how to make more crops on the same amount of land, right? So that's what we were getting into. We talked about irrigation, right? We talked about irrigation meaning how we get water, what the water does, right? So we talked about a lot of things that had to do with agriculture already. We talked about GMOs. We talked about genetic engineering. So we covered a lot of agriculture. This is another part of agriculture. You should have the slides open. I posted them about 15, 20 minutes ago. And the slides are for lesson 6, and it is called What Are the Costs and Benefits of Pesticide Use, right? So that's what you should have up. We're doing this the same way. We're going to continue doing this with the slideshows. I'm going to go live in case you have something to say. I'm going to go through each slide and I'm going to set up your assignment for the day and give you some heads up on what you need to do for your assignment to turn in for a grade. And then we're going to continue this way. I'm not going to do meets and stuff like that because it seems like, and I don't know if I mentioned it to you guys, but it seems like live, I only get a few people at that very moment. I mean, some classes I'll get 5 or 6 or 7. But for the most part, I don't get too many live viewers, or people will check in and then split. But the best part about using YouTube Live is it automatically posts right to the classroom. And when I go back and I check at the end of the day, which is the important thing, and I check the views on the videos, the views are up there. For most classes, the views are up there in the 20s. So people are getting to it. You guys are getting to it. It's just at a different time, and I'm cool with that as long as the work is getting done. Just to let you know that. Continue to send me private messages if you do work and you need it graded late. All right. So if you see a grade in gradebook, whether it's a 0 or whether it's a grade or whatever, and you do it after you see those grades in there, I'm not going to know that you did it unless you private message me and say, Graf, handed this in late, check it out. No problem. But you have to contact me. All right. I believe grades are due tomorrow. So, if you have any issues, you got to get with me today. I'm on all day, so you can email me or private message me all day. But it would be good if you made sure that, look, this is what I'm getting, because most of you are in great shape, but some of you didn't do a couple of things. And I need to know if you did them. The only way I can know that is if you private message me. Okay, to the slides. You should have the slideshow open. We're going to do it the same way. I'm going to go through the slides and sort of break down each one. We're talking about pesticides today. So when I look at slide 2, that is the agenda that we always have. You can look at that at your leisure. Slide 3 is a review from what we've been doing in agriculture before. So it talks about arable land. There's some vocabulary words in here. Arable means able to grow on, rich soil, stuff like that. Can become desert, and that process is called desertification. Desertification is the process of land going from fertile to non-fertile for some reason, whether you use the dirt too much without crop rotation, whether the irrigation makes the dirt too salty. We talked about all that stuff a couple weeks ago. So this is a review slide. It's a cool article. If you want to click on it later, the Smithsonian Magazine, it's actually a pretty cool article. So you can check that out later. We're going to go to slide 4. Slide 4 is the objective. That is just that by the end of this slideshow, you should be able to explain the costs and the benefits of pesticide use. All right. So slide 5 starts the real deal here. Slide 5. First, you need a textbook definition of what a pesticide is, right? We know what pesticides are. You guys call them poisons, they're poisons, something that kills something, and that's not wrong. Pesticides, we do have to differentiate between pesticides because there's some pesticides that'll kill this, but don't kill that. There are some pesticides or there are some things that are safe for us, but will kill bacteria. We'll talk about those on the next slide. But slide 5, when we look at slide 5, this is the definition for pesticide. And a pesticide is any substance used to kill, repel, or control a plant or an animal that is considered to be a pest. All right. So pesticides kill plants and animals, depending on what pesticide you use. We do that when those plants or animals become pests, whether they're pests in our home or, who defines pests? Are they pests in our home? Are they pests in our agriculture and on our crops and destroying our food supply? So that's what pesticides are used for. Good morning. My daughter just woke up. All right. So there are different types of pesticides, right? So we have to break those categories down, and they're all very, very self-explanatory. You have herbicides, right? Herbicides. So the whole side thing, think of suicide, think of genocide, those horrible words, right? That is one way to that delineates that you are getting rid of something. So that's the dead side, the kill side. And the first word is going to tell you what it works for. So herbicide, herb is vegetation, plants, right? So herbicides are used for destroying weeds and other unwanted vegetation. All right. So whether you have Roundup weed killer and you're using it in your garden or around your fence or something because you don't want weeds to grow, right? That's an herbicide. Then we have insecticides. Insecticides, my favorite Nirvana album, by the way. Insecticides are for controlling a wide variety of insects. So when we talk about crops and we talk about agriculture, we talk a lot about insecticides because most of the pests that bother plants and agriculture are insects. All right. Then we have fungicides. Fungicides are used to prevent growth of mold and mildew. You may have used fungicides in your life where you are, the stuff you spray on your shower tiles. Sometimes when you come out of the shower, there's this spray. That's mold and mildew spray. What that is that's a fungicide, and it kills mold and mildew. All right. And then the last one is something that everybody's been exposed to and used, and that's disinfectants, right? Disinfectants, now it doesn't end inside, but disinfectants are for preventing the spread of bacteria. So you look at all these different categories and you see that these are all living things, right? You have vegetation, you have insects, which are animals, you have molds and mildews, and you have bacteria. So you have different pesticides to kill each type, all right, or control each type. There is a sound clip. There's a link to a sound clip on this slide. I want you guys to check it out later. It's only a few minutes. It talks about crop spraying. Very interesting. Some of these sound clips, there's a couple sound clips in this slideshow, and there's a couple videos. The sound clips and the videos you should definitely check out. None of them are long or tedious or difficult to understand, but there probably will be a question or two on the quiz about some of the stuff, some of the content in there. So just check that out. Okay. Moving on to slide 7. So what pesticides do, right, is pesticides, we know generally speaking what they do, but what pesticides do is when you spray them on crops, when you spray them on plants, typically what they're supposed to do is they're supposed to break down into their individual molecules over time. They're supposed to do their job, right, control the pest, and then they're supposed to break down. Problem is that sometimes these pesticides will drift in the air, especially when you're talking about crop dusting. The sound clip will talk about that, where they're spraying large amounts of pesticides over crops. Well, if the wind is blowing, that stuff, the molecules are light and they can be carried through the air like anything else. Also, they can move into the water cycle, so they can get into the water supply and they can stay in the water cycle for an extended period of time. Now, those two things equal us getting them into our systems, breathing or drinking, right? And it's especially dangerous, as it says on the slide, for pregnant women because they can easily spread it to their babies, right? And that last part is talking basically what I'm saying. If pesticides are floating in the air, if pesticides are in the water sources, if pesticides are in the soil and especially in our food, obviously it's very, very difficult to get that pesticide residue um, out of our diets, right? And there's a big word in this slide. It's called bioaccumulate. So when the pesticides don't break down enough to where they're completely harmless into their individual molecules, they bioaccumulate, which means they accumulate in the air, or they accumulate in the water, or they accumulate in the soil, or they accumulate in us. Okay, so bioaccumulation is an important word. Bioaccumulation is the buildup of pesticides or pesticide residue instead of it breaking down and sort of biodegrading. Okay, slide 8. Slide 8. Okay, so what happens when things are not so are pretty dangerous and are not so safe for us? Usually a government agency steps in, and that would be the EPA in this case, the Environmental Protection Agency, right? So the Environmental Protection Agency sets limits on the amount of individual pesticide that can be found on each food item. All right. So there's a problem with that, and there's a loophole with that that's always exploited. And I'm going to explain to you. I got to put my coffee down. Okay. So the EPA will say, okay, you have pesticide A here. You're only allowed to use this much. This is the safe amount of pesticide A. And oh, you have another type of pesticide too, and that's pesticide B, and this is the safe amount of pesticide B you're allowed to have on your food, and here's pesticide C you can also use, and you're allowed to use this much safely, right? So you have all these individual safety or safe amounts that you're allowed to use. Problem is, farmers, agriculture industry, they'll use the safe proper amount of pesticide A. They'll also use the safe amount of pesticide B, and they'll use the safe amount of pesticide C. So they've not broken any laws, but then they'll throw them all together, right? And then they'll use them. Now these limits were set as individual usage. There is no guideline for total pesticide on food. It's just that there can only be this much A, and only be this much B. There's a loophole there because when they mix them all together, they exploit that. The pesticides work together, they work more efficiently. You can put more of it on there, save more of your crops, make more money. But all of that pesticide is not good because then it all can't break down and it bioaccumulates. Okay. So that's the problem with that one. Now there's another sound clip there you can click on at your leisure. That sound clip talks about fruit washing. So we talk about produce and we talk about fruit, and we talk about how those are things that are typically sprayed down with pesticides, and we talk about washing them. Right, rinsing them off with water isn't the best thing. It doesn't work that well. It's not very effective. Some people use soap and water. Soap and water is effective, but then you have soap residue on your fruit and produce. And typically what that can do is cause digestive issues if you're eating soap. So you don't really want to do that. It's not super dangerous, but it just may cause sensitive digestive systems issues. So what usually the best way to clean your produce is to use a mixture of vinegar water. Vinegar is very effective at removing those residues, and if you I think it's equal parts vinegar and water, that's a very useful thing. All right, the picture on slide 8 is interesting, the diagram on slide 8. So you're looking at a picture of the typically dirtiest produce, right? Meaning they have the most pesticides can be found on them. And then you have the other side that is the cleanest produce, which typically doesn't have too many pesticides on them. When I was looking at this, what I had always thought, just general knowledge, because I thought about it and I made it logical in my head, was that pesticides would be more prevalent in more porous produce. Things with wrinkles in it, or things with holes in it, or things that it could penetrate and get into, softer fruits, lettuce, stuff like that, right? And if it had some sort of coating on it, like an apple has a skin or an orange has a skin, then it wouldn't be as bad. That was my general knowledge up until I sort of looked at this stuff. And when you look at the list, that doesn't jive. So I went to think again, which you guys should be doing, thinking about, well, why the heck are they on this side and they are on this side? And it turns out when you look at them, the left side are more desirable to pests. The right side, onions, not too many pests for onions because of chemical, because of taste, because of how they grow. Avocados are grown in an area where there's not too many pests, right? So you look down that list and you say, okay, well, it seems like the pests are more likely to enjoy this stuff. So it's more of a taste preference. And if you have more pests enjoying that produce, you have to use more pesticide to control them, right? So that's what that diagram sort of shows you. And it's true somewhat that if you're spraying a lot of pesticide on things like strawberries, it might come in. That's why we buy organic, right? So it says on the left side, dirty dozen. The dirty dozen of these produce items, typically you want to make sure they're washed, or you can buy organic, right? Organic, we're going to talk more about organic in the next presentation, but organic is grown without pesticides, all natural, right? So that's the way to go if you don't want any pesticide usage. But I'm going to talk a little later about how it's kind of useless as well. And then the right side is typically the ones you can get away with without buying organic, because organic is expensive. So they're saying if you have to do that, that's a good guideline. All right. Yep. Yep. All right. Slide 9. Okay. Slide 9. This is interesting. 3% of Americans tested by the CDC, we're all familiar with the CDC nowadays. 3% of Americans tested by the CDC had metabolites, had metabolic molecular pieces of a banned pesticide called a chloropyrifos. It's a neurotoxin, a neurotoxic insecticide in their urine. So 3% of Americans tested in their urine had this banned pesticide. Now, I'm not sure exactly when it was banned. You guys are going to have to look that up later if you choose this one. And it's a neurotoxin. It's dangerous, right? Neurotoxins can be very dangerous to humans. You think about nervous system, you think about brain, you think about muscles, you think about communication in your body. And neurotoxins are things like Botox is a neurotoxin. What it does is it paralyzes your muscles, right? So if you're taking too much of that in, that could be a problem. The next one is even more disturbing. DDT, right? DDT is one of those historically famous pesticides. Very, very useful, very, very cheap, very, very easy to make, right? And I'm not going to talk too much about DDT because you have to pick a pesticide later and sort of write about it. So, but DDT was used all through the 50s and the 60s, and it was amazing. It was great stuff. You yielded a lot of crop when you use DDT as a pesticide. Problem is, turns out that it is super, super, super dangerous to humans. Birth defects, developmental disorders, cancers, everything is linked to usage of DDT. We find this out, we realize this, right? Society realizes this, scientists realize this, and they ban it in 1972. Right? And you know how when we ever talk about anything in this class, we talk about how people didn't really start to wake up and think about the environment and start making legislation to protect the environment until the late 70s, early 80s. That's that whole Earth Day, green revolution thing, not green revolution in agriculture, but recycle green revolution. So that's when that stuff came in. So for it to be banned in 1972, what that's telling me is that it was super dangerous and they had to get rid of it. Because it was banned before anybody started making legislation about environmental protection. Even though DDT has been used since 1972, 99% of Americans tested positive for DDT degradants, which means byproducts, residues. Today, well, not today, but when this was written, current times, how does that happen? How do 99% of Americans still have DDT in their systems if it was banned in 1972? It didn't transfer from mom to kid, right? That doesn't happen. So what happens? Yeah. So think about it. DDT, whoever's making this, the industry, it's very, very popular. They're making lots and lots of money, right? All of a sudden, the government comes in and bans DDT. Well, we're not just going to shut our doors and say, okay, time to retire. No, that's not what big business does. So what big business does is they change a molecule in it. So now it's not called DDT anymore. It's called DDD or whatever. They'll rename it. They'll rebrand it. They'll change a molecule. So technically it isn't DDT anymore. And then they'll start selling it again, right? So really, all they did was say, you can't use DDT. All right, fine. I'll call it something else. I'll change something and we're good. That's what happens all the time in big business. They always find a workaround. I think in the 90s, gas stations, we figured gas with their pollutants. There was something in gasoline, and this is just off the top of my head, so I'm not positive. But there was something in gasoline where there was this whole attack on the oil industry, saying how dirty it is, saying how polluted it is, saying how it's killing the environment, and we need to stop that. We need to move more electric cars. But big oil isn't going to do that. Big oil is going to say, all right, what we're going to do is we're going to add something to our gasoline to make it more environmentally friendly. And they like threw like ethanol in it or something, and it made it cleaner. So now they can label it all over the place. Our gas is cleaner. We're striving to save the environment, when they really didn't do much. All right. So big business always finds a way. That's, I guess, the point of that. And we don't really know. We know that when you ingest these pesticides, they're not good for us, but we don't really know what the residues, when they start breaking down, when there's a little bit, we don't really know what that does to us over the long term, especially for some of the newer pesticides. So that's an interesting thing. All right, slide 10. Slide 10, slide 10, slide 10. All right, all this really says is that everybody's body works differently, and everybody processes things, food, chemicals, whatever. We all process things differently depending on our system, depending on how our organ systems work together. So when you do have some of these residues, there are people that react to it differently. It's like medicines, right? Some people can take a pain medication and it works well. Some people can take a pain medication and it doesn't work very well. Some people can take a pain medication, it can knock them out for 2 days, right? It's all how our body reacts to things. Same thing with pesticides, same thing with these chemicals. When they get in our body, some of us can process them, some of us that can flush them, as a matter of speaking. And then there's others where they can't. So what happens is something called toxic loading, right? You get more, and exposure is a big key too. If you're in an area where there's a lot, you're going to be exposed to a lot. If you're exposed to a lot, then you won't be able to process it all. And then toxic loading will take place. It will accumulate in your cells, right? And that's when you have problems. Evidence shows that children are obviously more susceptible to the adverse effects of exposure, just because, they're smaller, their systems aren't as developed, and it's easier for things like neurodevelopmental effects to take place. And think about nervous system, brain, muscle stuff. So neurodevelopmental brain development. So there could be a lot of problems when you're growing up next to farms and next to areas which use a lot of pesticides, right? You're going to find out in the next lecture too that we don't use a lot. We don't use a lot of pesticides. We do, but there are a bunch of steps that farmers have to go through before they can start using the pesticides that we're talking about in our heads, the dangerous ones. There's a bunch of steps that have to happen. There have to be a certain amount of pests. You have to have tried 3 different natural ways. We'll talk about it next time. But so just when we're talking about pesticides, it sounds so bad and so dangerous and it's everywhere, and look around. Well, typically that's getting better and better as time goes on, because we're finding new methods to control pests. Okay. All right. Slide 11. Slide 11 is where they talk about the actual issues that can be caused by pesticides. So when we look at societal problems nowadays, when we look at these ailments that seem to be growing and seem to be very prevalent in our societies, we see things like, obviously, cancer. We see things like ADHD in children has been on the rise for a couple decades now. Autism in children has been rising exponentially in children over the last couple of decades, right? And we also have things like, more and more prevalent over the last couple of decades, breast cancer in women. All of those things are linked to pesticides, right? Now, they're linked to other things too. There's genetic factors and there's all different kinds of links, right? There's a lot of variables that go into having one of these ailments. So it's not like this causes it, and if we stopped it, the ailment's going to stop. That's not what happens. But if you think about 5 or 6 different variables in a scenario, which could really increase your chances of getting something like this, if you can pull the variables out, like some variables you can't pull out, right at the moment in time, this moment in time, we can't pull out the genetic component, right? We can't figure that out where we can say, okay, cancer runs in the family, but we can just take that out. We can't take that variable out. But if there are variables that we can remove to make it less likely and you less susceptible to contracting these, well, that's something to explore. And if pesticides are one of those links, one of those variables, and we can remove that, we're just living a better life. It doesn't mean that you're not going to get these, not going to prevent it, but it's going to help in the long run, right? So that's what they're saying. There are, and you can look through these pesticides. There's something called organophosphates that's been linked to ADHD. Oh, the other one, the atrazine, the herbicide atrazine. So it's a pesticide that is used to control weeds and control certain vegetation. It can be found. Now, obviously, you're spraying that on the ground, right? Anything you spray on the ground and it goes into the soil, it's going to find its way to water. 94% of the water supply has this herbicide in it. 94% of our water supply. That's almost everything. And it's been linked to things like birth defects, infertility, and cancer. Those are huge, right? So these are just some of the things. Women exposed to a pesticide endosulfan during pregnancy are more likely to have autistic children. So these are just things that, could happen, or they become variables. Pesticides become variables in a lot of different problems. Slide 12. Yeah, well, let me go back. Slide 11. There's something else I want to say. Oh, and yeah, just on slide 11, it doesn't say it, but just to stay on slide 11 for a second. Um, the problem with pesticides is we can't control it. We can't control it. We can say, okay, this goes back to the organic slide. We can buy organic produce, right? We can pay more money for it, and we can buy it, and we can stay healthy, and this and that. But buying organic produce isn't going to keep pesticides out of your system. It's just not. It's going to help a little, but again, if this stuff is in the atmosphere, if it's in 94% of our water, right? 99% of Americans are testing positive for DDT. That it's getting in our systems in other ways. You also have to think about, okay, I'm buying an organic apple, I'm good, but you're also using corn and wheat, which is pretty much in everything. That corn and that wheat could have been sprayed with pesticides. So if it's an ingredient in your food, you're also susceptible to that. So buying organic, of course, is a good idea because there's less of a chance of having pesticides on your produce, but you're still getting in other ways. So it's kind of weird. Uh, anyway, back to slide 12. Here's the kicker, too. In bio, you guys did talked about something called antibiotic resistance, right? You talked about how we use antibiotics to kill bacteria. When we get sick and we have a bacterial infection, we use antibiotics to kill them. Well, we know that bacteria reproduce very quickly, right? And there can be some mutations or some evolution there that will make a certain bacteria resistant to that antibiotic. So that antibiotic can't kill it. So that one bacteria or that couple of bacteria, most 90% of your infection goes away and gets killed by the antibiotic. But there's a couple of those suckers that live. And what do? They reproduce and they pass their DNA on. And then inside their DNA, they're coded for resistance to this bacteria. So over and over and over, you have this colony growing, you have this community growing, this population growing of bacteria that you can't kill with this antibiotic, right? Same thing with pesticides. Pesticide resistance is increasing. So pests are becoming resistant to the pesticides, which really sucks because pesticides are typically very useful. They can be very dangerous, right? So there's pros and cons to pesticide use. They're cheap, it's effective, whatever. But it's becoming less effective. And if you look at this slide 12, you'll see that in the 1940s, farmers would lose about 7% of their crops to pests, right? And that's an acceptable loss. That's what they call that. When you're growing crops and you lose 7% to pests, okay. They were using pesticides, right? And they were probably, not sure of DDT, but they were using pesticides of some sort. But they were still losing about 7%. Not too bad. As the years go on through the 40s and the 50s and the 60s, they see that, okay, well, that 7% lost crops is moving up to 8. It's creeping up to 9. It's creeping up to 10. Wait a second, that sucks. I'm making less money, right? So they start using more of their pesticide because they want to get that number back down to 7%, right? So it's going up, it's going up. They're using more and more pesticides. They're using different pesticides. In comes DDT, right? But they don't want to go from 7% to 10% because that's a big loss of money for them. So they want to keep it at that 7%. So they're adding new pesticides. They're using more and more pesticides, right? By the 80s, the percentage increased from 7% to 13%, which is a big increase. Even though more pesticides were being used and combinations of pesticides were being used. So they were like, doesn't make much sense. So here comes the scientific community. They check and they realize that a lot of these pests, more than 500 different types of pests, have developed a resistance to the pesticides since they started using them in the 40s. So we're using these methods that are dangerous to living things like us, and they're not even working as effectively because pests are becoming, they have mutations, evolution, and they become resistant to these pesticides. So that's kind of interesting, right? So what are we doing, right? The next slideshow, the next time we meet, which is Friday, I think, that day, we're going to talk about how there's different methods and you don't have to use pesticides. So there's a big system put in place where you can't just go spraying your pesticides with DDT nowadays. You just can't do that. You have to have a lot of methods that you've tried, a lot of things that you've done. And then you can spot pesticides, you can spot spray. And so the days of big airplanes flying over, dumping all these chemicals is pretty much few and far between, at least in the United States. There's a documentary on Netflix. I don't know if it's still on Netflix, but it was about the banana industry. I think it was called Bananas. You could probably find it on YouTube. I'm pretty sure it was called Bananas. And it's about the banana industry in, I believe, Costa Rica. And they show the workers with all these bushels of bananas working the banana fields, the plantations, I think they call them. I'm not sure. Banana plantation? I think so. And they're working these with all these bushels, and you see the planes literally flying right over them, dumping all these pesticides on them because it's not as regulated in other countries. And these guys are literally, these men and women are literally wearing raincoats, and it's all over them. And they go home, and the documentary talks about how there's so many different medical issues with the families that live around there and the people that work there. It's actually a very interesting documentary. Check it out. I'm pretty sure it's called Bananas. All right. When we go to slide 13, we see that there are 2 videos there. Check them out. I'm not so sure if there's any questions on the quiz about them. Maybe. But one is called Pesticide Drift. It's only 2 minutes. It's a very interesting video. The other one is called Be Aware. It's 4 minutes. Mr. Chalet would love this because it's about bees. And we know how important bees are. We've talked about how important bees are, keystone species. We talked about how important they are to our food supply. If bees go away, our food supply is going to be hurting. We're going to have a lot of problems. So this talks a little bit about being aware and how bees are affected by pesticides. And then slide 14 is what you're doing. Slide 14, and not too much. You're just back from spring break. I'm not going to kill you too much with stuff. You're not writing an essay. You wrote an essay on genetic engineering. I'm not asking you for an essay. What I'm asking you for is to research a pesticide of your choosing. That's why I didn't talk too much about DDT and the other ones. So easily Googleable, list of pesticides used in the United States or wherever the heck you want to look at. And you can pick one. DDT is very historically famous, so you can use that one if you want. And you're going to write a paragraph. Give me 4 or 5 sentences. I don't want an essay. Unless you want to go nuts, then go nuts. But I want it written with your own fingers. I don't want it copy and pasted. Research pesticide of your choosing. Tell me a few things in this paragraph. What was it made for? What was it intended to do? Right? What was the positive of it? We're going to use this to control, boom, because this is a problem or whatever. And then also tell me the pros and cons of it. So when they started using it, what did it do? Did it have negative effects? Was it linked to anything? Just a quick boom, 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 4 or 5 sentence thing, and then turn that in. All right. So, like I said in the bottom in the comment notes, give me a solid paragraph, a good one. If you want to write more, feel free. You don't have to use DDT. Look at the list of them. One of them might strike you as holy cow. Like one of them might be super, super dangerous. One of them might be really good. Whatever the case may be, you can check it out. And it doesn't have to be just in the United States. You can look around the world for pesticide usage, and that's cool. All right. That's what I have for the slides. The next slideshow is going to be about how we try to put in place ways to avoid using these dangerous pesticides. So we'll get to that on Friday. And then that'll be the last slideshow. And the next time we meet a week from today will be a quiz. So you should be looking at all the agriculture. We're on lesson 6 here, right? And then there's a lesson 7, which will do on Friday. So from lesson 7 all the way back to lesson 1. So you should go back to those slideshows. I forgot the date. I want to say it's 3/27. That's just screaming in my head right now. Easiest way to do it is to go to the last quiz on the Google Stream. I'll tell you more about it Friday, but go to the last quiz that we took on the unit exam on the stream, and then the next day, the next set of materials, that's where our stuff starts from. So I think it's 5 slideshows up until today. So look through that stuff. I'll give you a bit of a review, and then we'll talk about what's going to happen next week. Again, this is all 4th cycle from this point on. So if you have any issues with 3rd cycle, you've got to private message me and get with me immediately, because grades are due tomorrow, I believe. All right, I'm out of here. I'll talk to you soon. Talk longer today than I usually do, but that's cool. All right, see you later.